All right, we're going to try to do another one of the sample homework problems. So this one says in the following exercises, change the order of integration and evaluate the integral. This is going to be a little bit more complex than what we would do over a rectangular section. I'm going to have to do a little bit of work here. All right, so first of all, we would be doing the dy of sine of x from 0 to the line x plus 1. So let's draw that out here. All right, so the line x plus 1 goes off like that, right? So this is, again, this is x, this is y. All right, now after that, we're going from -1 to pi by 2. So we're going to constrain this to this point here. This is going to be -1. And pi by 2 is around a little over, what, 1.5? So, I don't know, some point here is pi by 2. So the area of interest is in here. That's what we're looking to do. So we want to flip that around, and so instead of going from 0 to x minus 1, so where we would be going up from 0 to x minus 1, x equals 0 to the line x minus 1 there, we're looking to go the other way. So how we would switch it up is now we're going this way. That's not what I wanted. So now we want to do it this way, and we're hitting first the line x plus 1, and then we're hitting pi by 2. So essentially, so new, we want y minus 1. That's what this is going to turn into. So x equals y minus 1, because we're dealing with the x. That's going to be less than or equal to x, and then we're going up to what, pi by 2. So that's going to be our left to right. And our y, we're going to be going from 0. Again, we're starting at 0, and we're going all the way up. Our lowest point will be 0. Our highest point will be just pi by 2. No, hold on. It's 1 plus pi by 2, because it's going to be here. So this point here is 1 plus pi by 2. Okay? So that's how we're going to have to rearrange this. So let's do this. So this equals, these are going to be the first one that we're going to go with x first. We're doing dx first. So our x's are y minus 1 to pi by 2. And again, we want dx first and then dy after. And then our y's are changed to 0 and then 1 plus pi by 2. All right, so let's work on that. I'm going to do the inner part here first. All right, so the integral of sine is going to be negative cosine. And that goes from y minus 1 to pi by 2. And then we're going to have a dy on the outside. So that equals, what do we have left here? All right, so it's going to be negative cosine of pi by 2 minus cosine of y minus 1. All right, so we can evaluate at pi by 2. At pi by 2, that's just 0, right? So this part here equals 0. So we have a positive cosine of y minus 1 evaluated with respect to y. So that's where we're at right now. All right, so again, this is going to equal negative cosine, not negative, just positive sine. Integral of cosine is sine. So we're looking at sine of y minus 1 evaluated from 0 to 1 plus pi by 2. And that's where we're at right now. So that's going to be sine of 1 plus pi by 2 minus 1 minus the sine of 0 minus 1. So that equals sine of pi by 2 minus sine of negative 1, or this part here can be plus sine at 1. Sine of pi by 2 is going to equal 1, so 1 plus sine of 1 is our answer.